All right, number 15 says use your calculator to continue in part 4. Now, for everybody who was there last class, I had a bunch of calculators I lent out, these kind, and we saw how these calculators can do recursion very conveniently for us. So let's go ahead and do part 4. There's actually two part 4s. We'll do the one here first, the blue one, when the seed was 0. Recall with this calculator then, with a clear screen, if you enter the seed, 3, and then hit the enter button, bottom right. Next, we'll apply the rule, which is the previous answer. And over here, on this negative sign, above it in yellow, it says ANS, answer. Well, that represents the previous answer, so that we can do recursion. But the previous answer should be squared according to this rule. So we'll hit the yellow button, second, answer. Then we'll hit this button where it says x squared. Previous answer squared decreased by 2. So we're using the seed 3 right now, so this would be iteration 1 when we hit enter. And after that, you don't need to hit answer or squared or minus 2 anymore, you just hit enter again. There's iteration number 1, you can see it matches what our work was in blue. Iteration number 2 is 47, iteration 3, iteration 4. Looks like I made a mistake there with our iteration 4. It should have been 4,870,847. Yeah, even iteration 3 looks like I made a mistake, 1762. Iteration 5 would be very large. When the calculator shows an E13, it means times 10 to the 13th, which is scientific notation because it's such a large number. Let's go and do the other number 4. Oh, by the way, those blue numbers there, number 14, appear to have been wrong. It should have been 747, 2,207, and then 4,870,847. The other number 4, let's clear the screen. This time the seed is 1/2. Enter 1/2 and hit the enter button. Next, let's do second answer. Squared key, minus 2. So iteration number 1, iteration number 2, iteration number 3, and 4. Looks like I made another mistake there with iteration number 4 in green. I don't know what I was doing. It should have been negative 1.24. Alright, iteration 5, 6, 7, 8, 9, 10, 11, and 12. And we can just keep going. And I'm up to about iteration number 40 or 50. And it seems pretty random. The behavior of these iterations seems pretty erratic, bouncing around from negatives to positives, but always staying within 2 units of 0. So I think that takes us to the end of number 15. The seeds that seem to exploded, that definitely exploded, was a seed of 3. None of the others exploded though. Alright, some review with the statistics. I'll start quickly with the mean. Divide by how many values there are. So the mean is 40. standard deviation is equal to the square root of 1 divided by n. And remember, n is the number of data values, and there's 1, 2, 3, 4, 5. And recall that this symbol means we're going to be adding this over and over and over again. So use a bracket, then x sub I means the first individual x value, which is 12, and we subtract the mean, which we've already determined as 40. Individual x value minus the mean, in parentheses, squared. And this symbol means keep doing that over and over and over again, adding each result. There's 5 values, so it will happen 5 times. And every time it's minus the mean. Next individual x value after 12 was 20. And then 20 again. And then 30. And then 118. So the standard deviation is about 42. And in this problem, we were talking about the number of participants at a random sampling of 5 TDA events. So the standard deviation is about 42. The average number of people was about 40. That was the mean. The standard deviation was about 42. So the typical deviation from the mean of 40 was about 42. Alright, the minimum value is 12, the maximum value is 118. There's 5 values. They are in order. This is the one in the middle, so that's the median. For the quartile 1, we look at the bottom half. We do not include the median and average them. The average of 12 and 20 is 16. And then for the 2 values above the median, 30 and 118, average those, and by average we mean find the mean. So the sum of them is 148, divided by 2 is 74. So that's our third quartile. And these 5 numbers, the 5 number summary, are what we use for the box plot. Go from 0 up to about 120. Minimum, maximum. Quartile 1 is about 16. Median is 20. Quartile 3 is 74. Those 3 parts give us our box. Max and min give us the whiskers. Don't forget to label the axis. Any graph should have some kind of a label. All right, and we're done with that one.